Introduction to Spreadsheet Graphing. There are two learning objectives for this lesson. First, we want to make sure we understand continuous versus discrete data. And secondly, we want to learn how to create a chart or a graph in a spreadsheet. In the last video, we introduced the concepts required for calculating mean, median, and mode using a spreadsheet. Now let's go back and work with our test marks a little bit more. Supposing we wanted to get a visual representation of what the student or how the student is doing with their grades. A really nice function that we've got, if we highlight the data, we can click and drag over those two cells. We can go to the Insert menu and say Chart. Takes a few seconds, and Google will come back with a chart. So each of these bars represents each of these marks. So you can see test number 1 was 90%, so there's the 90% mark. Test number 9 was 23%, and you can see down here it's just a little bit below 25, so that's showing 23%. So you get a very good visual representation of how this student is performing. They were sort of slowly declining, then really went off base and got a little better again, paid attention, and then really bombed the last couple of tests. So this is the right kind of chart to provide when you have what we call discrete data. So there are single data points, and there's no points in between. So there's no test 1.5. You can have test 1 or test 2, but there's no point of data in between. However, let's look at a different kind of data. Supposing we've been calculating temperature, tracking temperature, and over time. So at 9 o'clock, we've got 15 degrees, at 10 o'clock, 17 degrees, and so on, all the way through to 11 o'clock at night. If we plot this type of data, go ahead and do an Insert Chart again. This time, it gives us a different kind of chart. It's given us a line graph. Now I'm going to modify this line graph just to make it a little easier to understand. So I'm going to go ahead and edit the chart. And you can see on the right-hand side, it gives us the ability to kind of customize it a little bit. So I'm going to go to the grid lines and ticks, scroll down here, and we're dealing with the vertical axis first of all, so that's the one that goes up here. So we're going in increments of 0, 5, 10, 15, 20, 25. And so I want to introduce a minor step here, or minor count change of 4 intermediate steps, right? Because we go from 0 to 1, 2, 3, 4, 5. So we've got 4 counts in between each of the major spaces. And the same thing along the horizontal line. I'm going from 9 until noon. I'd like 10 and 11, or at least some indicators of that as well. So I can go here and change the horizontal axis, and I'll change the minor count spacing to 2. And so now you can see here is a spot for 10, and here's the spot for 11. I don't have to have it on the legend. I don't have to have it on the titles here, because that would get super crowded. But now it's very easy for me to see what was the temperature at 10 o'clock and what was the temperature at 11 o'clock. So what's important here is that the temperature didn't jump from at 9 o'clock. It didn't just suddenly jump to 17 degrees at 10 o'clock, right? It had to pass through every temperature in between 15 and 17 degrees, right? So at 9:30, it was probably at 16 degrees. And at 9:45, it was probably at 16.5 degrees before it got to 17 degrees at 10 o'clock. So when you have a line connecting your data points, you use a line when you know that you can choose points anywhere along that line. Remember, if we go back to mean, there was no meaning to being at 1.5 on the horizontal axis, because you can't be at test 1.5. But you can certainly be anywhere from 9 until noon. You can be at any point along that timeline. You can be at 9:01 and 1 second, right? So, and there's going to be a temperature that is probably valid for that time. So when we're choosing data, or when we're reading off a graph at some point that was not in our original data set here, for example, like I said, supposing we wanted the temperature at 9:30, we're allowed to look at our graph and say, okay, well, it looks like at 9:30 at halfway along, it was pretty much at 16 degrees. When we do that, it's called interpolation,
or interpolating the data. So it's important that you're using the right type of graph for the type of data that you're using. For something where you have time and temperature, then a line graph is appropriate. However, when you have discrete data, not continuous data, then a bar graph is the more appropriate type of graph to use.